You're probably treating Google Antigravity like just another AI chatbot.
Uh-huh.
If you're opening it up, using it like a glorified text editor just to ask for a single function, you are completely missing the point.
You really are.
The revolution isn't about code generation, it's about coordination.
Welcome back to the deep dive. This session is really for you, the developer who wants to move beyond just asking an AI to write a function.
Right.
And really start commanding a whole team of autonomous agents.
Exactly. Our sources show that Antigravity, it functions as a full orchestration platform, not just a simple coding assistant. So our mission today is to master that shift. We're calling this new paradigm vibe coding.
I like that.
Yeah, it's where you stop writing lines of code and you become the tech lead managing an entire AI team.
And we've distilled this whole process down to 7 mission-critical features. We're going to cover true parallel execution with the agent manager, correcting agents in real time with asynchronous feedback, ensuring quality with artifacts, enabling self-healing UIs through browser automation, systematizing tasks with custom workflows, fixing that common review policy mistake, and then optimizing your credit costs with smart model selection.
Okay, let's unpack all of this. We have to start with the single most critical change in architecture.
Yeah.
The move from a linear chat history to a full mission control dashboard.
Let's do it.
So when we think about the current AI coding tools, GitHub Copilot, maybe Claude Code, what's the biggest frustration?
It's the black box.
It's a total black box, right? You put in a prompt, you wait, you get this huge block of code back.
Yeah.
And if it fails, you have zero visibility into why.
None. You don't know why it made that choice or where the plan went wrong. It's completely opaque.
And that lack of visibility, it just kills any complex project.
It does. And Antigravity flips that script entirely with the agent manager. You're not interacting with one single massive thread anymore. It's an inbox-based system.
An inbox.
Yeah. So every agent you create, let's say a researcher, a front-end specialist, a back-end engineer, each one gets its own dedicated thread.
And the beauty of that, I assume, is the real-time monitoring.
That's it. You can click into any agent's thread and you see 3 levels of transparency. First, its thought process, the reasoning behind its moves.
Okay.
Second, the step-by-step execution plan it's building. And third, the real-time activity log. You can literally watch it, browse documentation, write code, run tests.
So you aren't guessing. You're actually watching.
You're watching. We saw this almost jaw-dropping demonstration of this when our source started building a market intelligence app. Let's just call it the MI app.
Okay.
The user gave one broad prompt and then spawned 3 agents at the same time.
So you had, what, a researcher agent that started browsing SDK docs?
Right. Instantly. And at the exact same time, a front-end agent began scaffolding the React components.
And the backend agent?
Simultaneously setting up Python Fast API routes for the data API.
So that is the architectural shift. You're not waiting for the researcher to finish before the front end can even begin.
No. They're all running in parallel, coordinated by the main platform. I mean, this isn't just multitasking. This is true orchestration. It just eliminates the need for you to write thousands of lines of, glue code.
So how does this shift to parallel orchestration fundamentally change the developer's day-to-day role?
You stop coding lines and instantly start leading a technical team. You're like a project manager or a tech lead.
Let's pivot to a frustration I think everyone feels.
Oh, this next one hits close to home for me.
Yeah.
I mean, I still wrestle with this myself sometimes. It's the prompt drift.
Right.
You spend 10 minutes crafting this highly detailed, perfect prompt. The agent gets, say, 75% of it right, but then it adds some weird unwanted feature, maybe a user profile section you didn't ask for.
And in the old way, that just kills your flow state. You have to scrap the whole thing and restart the prompt from scratch.
Exactly. It's so frustrating. The asynchronous feedback system in Antigravity is designed to, surgically fix that. It lets you inject corrections while the agent is already working.
The build doesn't stop.
The build doesn't stop. So imagine that MI app build.
Yeah.
Your front-end agent generates its first task list, and you see it includes advanced charts and graphs. You know that's scope creep for your MVP.
Okay.
You don't stop the agent. You just click the little checkbox next to that task. You leave an inline comment right there like, remove this from the MVP entirely, and you hit submit.
And the agent just gets that signal and adjusts on the fly.
Immediately, it receives that signal, it dynamically updates its scope, and it adjusts its entire remaining plan without failing or restarting. It's like gently steering a ship instead of resetting the GPS every 5 minutes.
This process prevents starting over. But if you're injecting changes mid-task, is there a risk of, I don't know, breaking the agent's internal logic flow?
The agent is built to immediately adapt its plan, ensuring you course-correct the scope without triggering a catastrophic build failure.
That leads us right into artifacts. Because the speed of autonomous AI coding is, it's only useful if the underlying architecture is actually sound.
Absolutely.
Letting the AI fly completely blind,
Yeah.
that can result in some pretty mediocre code.
Oh, yeah.
Yeah.
And really questionable architectural decisions. Vibe coding isn't chaos. It's controlled speed. We need human judgment applied where it matters most.
Which is at the planning stage.
Exactly. And artifacts are these structured documents that the agents generate as checkpoints before any major code gets committed. They include task lists, but also detailed implementation plans and walkthroughs.
Walkthroughs are like change logs.
Yeah, essentially dynamic change logs. So think about the MI app again. If you ask the agent to create a feature with heavy data processing, it might first generate an implementation plan.
Okay.
And that artifact might say, we will use a SQL-based database for this.
And here's where the human comes in.
This is the moment. If you know that app is going to handle massive, unstructured, real-time data, you review that plan and just comment, no, SQL is too rigid, pivot to Mongo Atlas immediately.
And that 30-second intervention just saved the agent hours of writing useless code.
Hours. You refine the plan with your taste and your judgment before a single line of final code is written. That's the core of the whole plan, refine, orchestrate cycle.
So artifacts represent the critical application of human taste and judgment to counter raw AI speed.
They ensure core architectural decisions are validated and corrected by the human, preventing major refactors later.
All right, let's talk about the absolute drudgery of post-build verification.
Oh, this part is my favorite. You finish coding the MI app UI, and then what?
You spend hours manually clicking through everything, testing every button, taking screenshots. It's tedious.
It's painful. Antigravity gets rid of that by integrating a persistent, controllable Chrome browser. It can run headless in the background, or you can watch it. The agents themselves control it to verify their own work.
So that's a paradigm shift for QA.
Huge. The user can just give a command like, launch the browser, audit the entire UI, and provide a grade from 1 to 10.
And the agent, it just does it.
It opens the browser to your local host, bot 3000, it navigates the app, and it generates a formal audit recording. And here's the crazy part. It critiques its own creative output.
What does that look like?
It might say, current UI grade, 6 out of 10. Error. The data charts are still using the old dark color scheme, violating the new design system.
It finds its own bug.
It finds the bug, recommends a fix like update the CSS variables, and if you approve, it automatically executes the fix and then re-audits the UI to confirm.
Wait, hold on. That sounds amazing, but isn't relying on the AI to critique its own work just asking for confirmation bias? Like, how reliable is an AI grading its own homework?
That's a fair question. But the audit is based on functional requirements, not opinion. It's testing against the artifacts it already generated. Plus, you can watch the whole recording of the audit yourself.
Whoa! Honestly, I'm still processing this feature. Imagine scaling that self-healing ability across a massive, complex application. You could eliminate entire QA sprints. That saves weeks.
It does.
It closes the loop, allowing the agent to test, critique, and automatically fix its functional issues based on defined objectives.
Which brings us to process efficiency.
Right. If you're anything like me, you suffer from prompt fatigue. You're constantly retyping these detailed methodological instructions.
Oh, the busy work. Perform systematic debugging, or refactor this entire class following the Airbnb style guide.
Yeah, those 200-word prompts, they just become exhausting to repeat.
That is where custom workflows bring in some real rigor. They let you store these high-leverage, structured processes as reusable assets, and then you can trigger them instantly with a simple / command, like a debugging workflow.
So you're institutionalizing best practices.
You are. If the file upload feature on the MI app breaks, you don't have to panic. Our sources showed a systematic debugging skill that forces the agent through a predefined 4-phase process.
What are the phases?
Root cause investigation, pattern analysis, hypothesis testing, and only then implementation, which always ends with a regression test.
And the big benefit there is the methodology.
It's the methodology. Instead of typing that huge paragraph, you just type at debugging workflow.
Oh.
The MI app file upload is broken.
And that prevents the classic whack-a-mole debugging, where a quick fix just creates 3 new bugs somewhere else.
Exactly.
How does having a systematized forced debug task fundamentally prevent the creation of new bugs?
It forces the agent to methodically analyze patterns and dependencies instead of just applying a rushed, quick fix solution.
All right, we have to talk about what you call the autonomy paradox.
Yes, this is so important. If the agent has too much freedom, it can make really destructive changes.
But if you micromanage it, you kill the whole speed advantage of using AI in the first place.
Right. And the critical insight from the sources is that these agents they're inherently over-optimistic about their own skills.
They don't ask for help.
They rarely ask for a review, even if they're about to do a major refactor on a critical file. So Google simplified the policy down to just 2 options: always proceed or request review.
And the takeaway here is vital.
It is. When you're starting the MI app or any new project, you have to toggle request review on. It forces the platform into that plan, then execute rhythm, making you validate the artifacts.
And the strategy here is dynamic.
Totally. You toggle it on in the early stages to make sure your architecture is solid. But once the project stabilizes, you can toggle it O by IF and just rely on that asynchronous feedback for maximum speed.
So since the agent is typically over-optimistic, when is request review most critical to ensure quality?
It must be enabled early in the project lifecycle to validate and lock down foundational architectural decisions.
All right, our final feature, this one is all about optimization.
Which really means cost control, let's be honest.
It does, and the single biggest mistake we see people make is running every single task through the newest, most powerful, and most expensive model, like Gemini 3.0 Pro.
You're just burning credits unnecessarily. You really need to adopt a strategic 3-model approach.
Okay.
Different models are good at different things. Running a massive model for documentation is, like digital malpractice. Gemini 3.0 Pro should be your orchestrator. Yeah. It's optimized for this architecture, multi-agent stuff, artifact generation, browser automation.
And then you have the deep thinkers.
Right. Think of models like Claude Sonnet 4.5. This model excels at pure logical reasoning. So complex algorithms, heavy debugging, refactoring legacy code. It might be a bit slower, but the logical output is better for those specific tasks.
And the third category?
The janitors.
Yeah.
Or utility models like GPT-OSS. These are perfect for the low-stakes, high-volume stuff, generating markdown docs, basic code formatting, simple boilerplate. It's cheaper, it's faster for those jobs, and it's good enough.
So your workflow becomes highly strategic.
It does. You're using Pro for the MI apps UI build. You switch to Sonnet for that really complex debugging task. And then you use GPT-OSS to write the readmes. We saw one user save over 80% on their build just by doing this.
So what's the core rationale behind switching models for different parts of the development process?
Strategic model switching leads directly to faster builds, measurably better code quality, and significantly lower costs.
So if we pull all 7 of these features together,
you get the complete vibe coding workflow. It's a systematic framework for building production apps at, breakneck speed. It's how you move from being a coder to a commander.
It starts with the plan. You use the agent manager to spawn your agents, and you make sure that review policy is set to on.
Then you refine. You review those key artifacts, like the implementation plan, and you apply your human judgment using those inline comments.
Next, you orchestrate. The agents execute those plans, working in true parallel, coordinating the front-end, back-end, and research all at once.
And then you verify. The agent launches Chrome, audits the build, self-grades its own work with the automation feature, and fixes any errors it finds.
You systematize. For any repetitive or complex task like debugging, you use the custom workflows with a simple @ command.
And finally, you optimize. You strategically switch models based on the Task Pro for orchestration, Sonnet for deep logic, and OSS for the janitorial tasks.
The central theme we uncovered today is that Google Antigravity isn't just an evolutionary step for the chatbot, it's a fundamentally different paradigm.
It really is.
We're watching the shift from a linear single-input assistant to a complete distributed orchestration platform.
And this is all realized through true parallel processing, the ability to inject real-time feedback, and these self-testing capabilities that can eliminate weeks of traditional QA. You're no longer waiting for the AI.
You're directing it, like a highly efficient team lead.
Exactly. The developers who are going to win in this new era, they won't be the ones who can write the most code.
They'll be the ones who orchestrate the best.
The singularity is, it's already here in the development workflow. The only choice left is whether you're going to master orchestration and manage your AI teams, or keep writing code line by line like it's 2020.
Thank you for joining us on this deep dive. We encourage you to think about how you can immediately apply this plan, refine, orchestrate, verify framework to your own projects, regardless of the tools you're currently using. We'll see you next time.